to get us started with class. Okay? And we will do one more bell ringer to make sure we understand a really, really important principle. So let's stop the bell ringer, let's look at it. So I will point this out. This is probably a little bit more, it's not probably, this is a little bit more complicated than what I've been asking you to do, but the principles have not changed. Even though it looks very different, what is the, which quadratic form should this remind us most of?
Vertex.
What detail tells us that this should remind us most of vertex form? Okay?
This one.
Where that exponent is, right? X minus h squared. And I can simplify this to get exactly to my vertex form. So as soon as I see a vertex form, because you have this on your test, as soon as I see vertex form, how should I approach solving this? Inverse operations with those properties of equality. Remember, if I change one side of the equation, I have to change the other by the same amount to create what type of equations?
Equivalent.
Equivalent equations. I want equations that look different but tell the same story. And so we now need to think through what is the order that I want to do my inverses. How do we decide which inverse to do first?
The last thing you do in the thing.
The last operation being applied in that expression. And that's why I made this one a little bit more complicated, but where do you always start to read your equation? It's not just the left-hand side. Where do you start with reading your equation? Well, try to figure out what the first thing is. How do I read the equation to know what the first operation is?
I don't know. PEMDAS?
Okay. Backwards PEMDAS, we're going to go reverse of PEMDAS, but what I'm asking is how do I read the equation? Where do I start reading this equation? Say that again. The x. I'm trying to solve for this x. I'm trying to find the solutions for x, right? That's where I start. So Hayden, what's happening to x first? It's being subtracted by 3. Miracle, what's happening to x minus 3? It's being squared. Grace, what's happening to x minus 3 squared? It's being subtracted by 8. Cam, what's happening to x minus 3 squared minus 8? It's all being divided by 2. What's happening to all of that, Naisha?
Being subtracted by 4.
Being subtracted by 4. Is there anything else on that left-hand side? No. So the first thing I'm going to do is get rid of that minus 4 by what? Adding 4. To create what number?
0.
So I am going to have to create a 14, but it's more about creating a 0. The whole point of inverses is to create what two numbers?
0 and 1.
Zeros and ones. And then because I created that 0, I have to add 4 to the right-hand side. Now you need to look again because I saw several students who wanted to add 8 at this point. But what is the last operation being done at this point?
Divided by 2.
If we read from x again, we're dividing by 2. So I'm going to multiply by 2. 2 divided by 2 is 1. Now we'll point this out because I saw someone do this, right, Naisha?
Yeah.
What's wrong with this? It's got a 2.
It's divided.
It's division by 2, right? We want to recognize and don't ever forget, and I will point this out. Y'all remember how you bucked and you hated it when I told y'all to really focus on 1 divided by 2? But it's helpful when we start to recognize what that fraction bar is instead of just saying over. Mathematical language matters. And so we have to pay attention to it to be careful. That's division by 2. I don't want to divide by 2 again. I want to multiply by 2. To create what number? 1. Alright, can I get a volunteer to tell me, by raising a hand, what the next operation that we need to do? Eliza?
Add A on both sides.
Add A. Is that the last operation being done?
Yes.
Oh yeah. Creating a, and I've got to make sure my equations are equivalent. Man, that equation looks way different than where we started, but is that an easier equation to deal with?
Yes.
That's the goal. Somebody else that I haven't heard from yet, next operation, next inverse. I appreciate Naisha, but I do want to get some other people involved. Let's think through it. Jalen. The last operation is what? Well, the last operation is a square, so I'm going to take a square root. Square root cancels out a square. X minus 3 squared, x minus 3, I canceled out that square root. X minus 3 is equal to
Positive and negative 6.
Why do I need a positive and a negative 6?
Cause you read two.
Why?
Because 6 times 6 is 36, and negative 6 times negative
6 times 6 is 36. Negative 6 times negative 6 is also 36. Right? These are the things that we did not know originally, and we've grown and we've learned. I need y'all to understand this, and I need to do a better job of teaching this. You don't learn things immediately. It takes time to learn things. It's okay, but let's make sure we're putting in concerted effort to learn it. Only one last operation now. I'm going to add 3 to create a 0. Remember, I gotta create an equivalent equation, so I do to one side, I do to the other. And so what is a positive 6 plus 3? 9. What is a negative 6 plus 3?
Negative 3.
There's my solutions.
Ah,
That is hands down the best we have done yet in solving those equations. Say again, Miracle? No, it cannot be just on that, but that is 2 or 3 of the questions on the exam. P.S.
wait.
It was originally 25, I got it down to 20.
Mr. King,
Okay?
what if you got negative 9 and positive 9?
So that means that you probably did 3, or you probably did positive, negative 3. What was it you said, 9 and negative 3?
No, negative 9, positive 3. It's the same thing as just the.
It's, yeah, you flipped it. I don't know where that came from. I'll have to come and look at yours, but I will point out, Traylon, for it to be 100% correct, it's a positive 6 plus 3, so that's a positive 9. And then a negative 6 plus 3 is a negative 3. So I'll come and look to see where it got off a little bit for you. It might have been that you accidentally here, if you had, that's it, if you had subtracted 3 instead of added 3, that would have created that, but that would be a small error, right? And by the way, I will point out, Tevin, first off, headphones out. I will point out, if Trayana got negative 9 and a positive 3 because she accidentally subtracted here, would she still score well on the way that I score your assessments?
Yes.
Yes. That's a small procedural error. Show me, though, what you know. And I will point out, and one of the things I will be looking for in terms of details when you solve equations, at some point on your test, should you make a note, maybe a quick sentence, about using inverses to create zeros and ones with your properties of equality to create equivalent equations? You cannot get to those 4s unless you make that note somewhere. I need you to tell me, not just work out the equation, but show me that you understand that conceptual side of things. You can still score 3s and 3 pluses without that, but based on your level of detail. But if you want to show me mastery of these things, you got to show me that extra information. Okay? All right. I have one more quick bell ringer. This won't take nearly as long. It is 1.2. This is actually out of your textbook on page, I don't know what page. I'm pulling it up. Just kidding. Page 81, I believe is what it's on. So if you go to page 81, you will get this this information about Angela and Dwight. So I'm going to give you 30 seconds to think on your own. By the way, the problem is on the calculator, you don't have to get out your textbook, but if you want to write your answer there, it is probably going to be easier to see in your textbook as well.
Okay.
I think it's page 81. So M1-81.
81.
Yeah, I was right, page 81. I did remember to record. So M1-81. So let's take 30 seconds, try to figure out what Angela and Dwight did wrong, and then I'm going to give you 60 seconds to talk about it. So 30 seconds to think silently, then you will have 60 seconds to talk. Hey guys, silently thinking. So again, I'll point out Angela and Dwight made the same mistake. You're trying to figure out what mistake did Angela and Dwight make. And I will point out, you don't have to work anything. You need to look at what they did. They made a very grave mistake. Okay, 60 seconds, start talking with your small group. Yeah.
He took it, he missed it.
Oh, they did wrong?
Yeah, it wasn't. Actually, you know what?
Okay, so what did they try to do to get started?
No, DJ Wright.
To go from step 1 to step 2? What were they doing there?
DJ Wright.
Okay, let me ask you an important question before y'all continue to think through this, because I think we're missing a detail.
They forgot that.
Well, they didn't forget the X. What did both of them do to go from step 1 to step 2? What are they doing to go from this step 1 to this step 2? Well, they did factor. Need y'all to pay attention to this. They did factor, right? You look at x squared plus 6x, don't they have a common factor of x?
Yeah.
X squared plus 5x plus 6. They didn't show the work, but I will point out a times c gives me 6. Factors of 6 that add up to 5 are 3 and 2. So x squared plus 3x plus 2x plus 6. These have an x in common, and yes, I'm moving quickly, but that's so that we can focus on the point of this. These have a 2 factor in common. Notice they both have an x plus 3. And so they are left with x plus 2.
Oh, they,
Okay, so did Dwight factor correctly?
no.
Yeah.
Yeah, they know.
X plus 3 times
Yeah, but
x plus 2. Okay, so they factored correctly. So where is their error? Because they made a very grave error.
See that, you gotta bring that system out.
They what? Well, but hold on. Even though they didn't show us separating into 4 terms, did they get the correct factored form? Yes. So they did the factoring. They did the factoring correctly. That's not the problem. What is the reason that we factor?
Aren't they supposed to be the same?
Well, these both have that x plus 3. That's a common factor, right? So we factor out the common binomial, and when I factor that out, I'm left with x and plus 2. That's fine. Guys, what is the point of factoring when solving a quadratic equation? So that we can use what?
Oh, they have it equal to 6.
Say that again for me.
They have it equal to 6 instead of 0.
Because we want factored form so that we can use what property? Zero product property. Can I use the zero product property?
No.
You cannot just set x plus 3 equal to 6 and x plus 2 equal to 6. If I do that, I want you to notice x plus 3 equals 6. I subtract 3, and I get x equals 3. Let's say I substitute that back into this equation. That gives me 3 squared plus 5 times 3 plus 6 is equal to 6. Is that a true statement? 9 plus 15 plus 6 equals 6? Nope. So if it's not equal to 0, can I use my zero product property? No. Don't forget that you have to have that quadratic equation equal to 0. What should Dwight have done first? Subtract 6. And then he would have had x squared plus 5x equals 0. This is why the first step I have up there is factor out the GCF. Do these terms have anything in common?
Yes, yes.
They both have a factor of x, don't they?
Yeah.
So if I factor out my x, I factor out one of those two x's, so I'm left with.
Yes.
I factor out that x, so I'm left with. And that's equal to 0. Can I use my zero product property now?
Yes.
Yes. X equals 0, and x plus 5 is equal to 0. Remember, we're not just factoring for factoring's sake, we're factoring so that we can use what property to solve that equation? Zero product property. But if your equation does not equal 0, you cannot use the zero product property. What should Angela have done first?
Equal to 0.
I need to get it equal to 0. How am I going to make that equal to 0? Subtract 7. 7 minus 7 is 0. And I got to make sure my equations are equivalent. So x squared plus 6x minus 7 is equal to 0. Notice that's that traditional standard form, equal to 0. Yes, ma'am?
Wait, so you're not doing 6x minus 7?
I am. But remember, 6x means that I'm adding x how many times? So can I do x plus x, or 6 times, and then subtract 7 from that and know what it is? Remember, hey, this is where y'all talk about like terms. You see how they're not like terms? That issue is, and this is what we got to remember, 6 times x literally means I'm adding x 6 times, and then I'm subtracting 7. I can't combine those. I can't subtract those, because I don't know what x is. Does that answer your question? That's why I always focus on the idea that multiplication is repeated addition. We want to recognize that here. I can't subtract them. Okay, but I have standard form equal to 0, so I want that factored form. What method are we using for that factoring process? The AC method, which tells me right away that I'm multiplying A and C. And remember, every time I write out my equation, it helps me remember it better. So what is A? A is, remember, x squared is x squared. It's 1. It's how many x squareds do I have? I have 1. What is C? So I get negative 7. And what do I need to do with negative 7? I've done step 2. Look at step 3. Guys, you can read step 3, it's okay. I need factors of A times C that add to B. What is B? 6. So what are factors of negative 7 that add up to 6? Negative 1 and? Those are the only factors of 7, right? 1 and 7. The 1 has to be negative, the 7 has to be positive. Does that add up to 6? And remember, this is where I separate into my 4 terms, because those become the coefficients of x. X squared minus 1x plus 7x minus 7 is equal to 0. I'm done with step 3. Moving on to step 4. What does it say? Of the first 2 terms. What do x squared and minus 1x have in common? So I'm left with x minus 1. What do, and I gotta do the same thing here, what do 7x and minus 7 have in common? Both have a 7. And remember guys, when you factor, it's like doing what operation? Well, it's undoing distribution, so we are d by d. When we factor out, we're dividing, guys. What is 7 divided by 7?
1.
So I've got 1x. What's negative 7 divided by 7? Minus 1, right? Well, that's a good thing, because that gives me both of these have x minus 1. Boom. Boom. Step 5 is the last one. Factor out the common binomial factor. What's in common? They both have x minus 1. Factor that out, so I'm left with x. And what with the 7? Plus 7. And because that factored form is equal to 0, I can use what property? Zero product property. Okay. And now I can solve. So to go from here to here, and I will point out, telling me that zero product property, telling me why you're doing this, that's an important piece of the puzzle to show full evidence of your understanding. Not just doing something, but recognizing that we're using the zero product property. Yes, Eliza?
I thought negative 7 divided by negative 7 is a positive.
Remember, we factor out a positive 7. Does that make sense? So, remember we wanted x minus 1. So we factor out a positive 7 to get a positive x minus 1. That's a good question. So I did want that quick little review of solving quadratics using vertex, when it's in vertex form, and of factoring. So do not forget, you want that factored form to equal what? 0. Okay? You want that factored form to equal 0. Alright. From here, so that you have the next full hour to work within your small groups, I'm going to come back to here and show you. So what I want us to recognize is you have the next hour to work with your small groups, and I built these groups out of what you said you wanted to work on. And yes, some of it, guys, is not perfect because I had to work everyone into different groups. But group 7, identifying types of functions and writing equations for a function. If you notice, guys, I passed out a couple of sheets, and I have a copy of them for everyone. If you want to work on identifying types of functions and writing equations for a function, first off, did you find that on the test? Yes. I also put some more right here. Okay? This is on the back side of where it says forms of quadratic equations practice. So everyone has that sheet. Writing an equation for a quadratic function and factoring to solve a quadratic function, that's group 6. So there are plenty of problems where we will see parabolas, practice writing an equation, and then factoring to solve a quadratic. If you notice this sheet, factoring problems, that's all this is. And on the back side we got some parabolas, right? Some quadratics, and there's some quadratics on this sheet. Group 5, I'm going to come talk to you to figure out what we're working on. Group 4, all things quadratic functions. We can find practice problems on the sheet, on the test, and also I've given you some more there. If you need clarification, let me know what to look at. Group 3, writing equations. Again, can we look at the test? Yes, there are practice problems there, but also there are problems on the 2 sheets I passed out. And then we have identifying types of functions and solving equations. Work together to figure out when you're working on those. And then group 1 is just solving quadratic equations. That's what you told me you wanted to work on. So tell me if you need help identifying where we can get some practice problems. But we should have those resources. I also have a few blank copies of your unit test on just white sheet of paper if anybody wants a blank copy of it. But again, I would have out my test to pay attention to, work from, see what you need help on. The stipulation today is this: you learn more together. So that means we need to be working on the same problem together within our small groups. You can use the vertical surfaces, you can use the desk, you can do whatever you want, but we need to be working on the same problem together. So that means negotiate with each other, talk with each other to figure out what problem we're going to work on. If you are stuck, what is your responsibility within the group?
Ask questions.
Ask questions. If you ask a question, you get your question answered, you learn something. If you ask a question and no one at the group can answer that question, that means that the whole group needs to be asking a question, because if you can't explain it, you don't fully know it. If someone at your group asks you a question, what's your responsibility? To answer it. Your job is to answer it, because if you take the time to explain it and can explain it to someone else so that they understand it, then you fully understand it. The discussion side of this is huge. Everyone benefits when we actively work with each other to grow and to learn. It is not weakness to say that I need to ask somebody for help. It is a strength to know how to work with other people to grow and to learn. Take advantage of the people in your small group. Take advantage of myself and Ms. Bauer as we navigate around the room to help everyone learn to the best of our ability before our test on Friday. I will point out, we have one more day after today to continue this review process, so I'm going to let you do a poll question again at the end of class to figure out what you want to work on tomorrow. But let's take the next hour to learn as much as possible. What are your questions about this process? What I'm expecting out of us today?
To be working
And to be working
together.
together. I want active collaboration. All right, let's go ahead and get to work. Please, again, feel free to use vertical surfaces. Get up. It is much more engaging that way. And let's get to some good learning. And again, if you want a blank copy of the unit test, let me know.